Hi everyone. Today we're going to look at lesson 10.8, which is the start of our graphing of trig applications. So lesson 10.7 got us ready for understanding the slight changes in our equation when we look at an application question, how our frequency, which now we really refer to as our b value, now might contain pi, and the numbers contained on our x-axis, which come from our period, will now not contain pi. Okay, so let's take a look at a question. Number one, we're going to look at this example that talks about tides at a beach. So it tells us that the ocean tides near Carter Beach follow a repeating pattern over time. They tell us that the amount of time between each low and high tide remains relatively constant. So on a certain day, the low tide can occur at 8:30 a.m. Just going to underline that. And the high tide occurred at 3 p.m. Okay. Then it tells us at high tide, the water level was 12 inches above the average sea level. That's at high tide. And at low tide, it was 12 inches below local sea level. Assume that high tide and low tide are the maximum and minimum water levels each day, respectively. Okay. So they want us to write a cosine function. Let me actually come back to my highlighter in this format. Okay, A and B are going to be real numbers that models the water level in inches above or below the average Carter Beach sea level as a function of time measured in hours, t hours since 8:30. So f of t is inches above or below sea level, and time in t is hours since 8:30 a.m. So before we even attempt this graph, let's really dissect this function, just like we have throughout this entire unit where we've been graphing these sine and cosine functions. We're being asked to graph one cycle of the function. So first, let's just think about what we used to kind of write first. We would talk about amplitude, then we would refer to the midline and the range. So I'm not going to go right to amplitude, but I am going to think about the fact that they told me that this high tide and low tide is really my max and my min. So if we think of sea level as the middle, we're going 12 inches above that local sea level and 12 inches below. So that must mean that my sea level is really acting as my x-axis. So let's think our maximum is 12. So our min, if we're going below sea level, I'm going to think of that as negative 12, which really means my amplitude is 12, since we're going above and below 0, which, again, just to get another visual here, our range is going to go from negative 12 to 12, and really our midline, since we're talking about sea level, that's really what we're referring to here. Sea level is the middle. That's just going to be y equals 0, so the x-axis. Okay, so really also you could think about there is no vertical shift. And they kind of hinted to this. If you look over here when they talked about the type of function, there was no plus a d value. And you'll also notice there's no plus or minus c with our t inside the function. So there's no shifting going on in this function for cosine. Okay, the other thing they told us was that the low tide occurs at 8:30 a.m. and the high tide is occurring at 3 p.m. So let's just get a little visual here. I'm just going to kind of sketch myself a picture of what we're going to be drawing. Okay, so if this is my f of t, and this is my t, again, they said we're starting at low tide because t is time since 8:30 a.m. That means this function is starting at its low tide, which is really starting at its minimum, which means it's a reflected cosine curve. Okay, so that would be, we're starting down here at negative 12. At some point we'll go up to positive 12. And they said from low tide to high tide, which means we go to the middle and then we make it up to high tide. This is where we use the time from 8:30 a.m. to 3 o'clock p.m. Now, if you count 8:30 a.m. to 3 o'clock p.m., that's 6.5 hours. So that means here, this would be 6.5, since t is hours since 8:30. And then if we completed this cosine curve, because they did say we're going to graph one cycle, if I then, came back to the middle and finished down at my minimum, if halfway was 6.5, 6.5, and then another 6.5, this is going to bring me all the way out to 13, which is an important number to know. The time it takes for one cycle, that's my period. So it must take 13 hours to go from low tide back to low tide. They didn't ask us to write the equation of this function, but just because we only really need one more piece, if we wanted to write the equation of this cosine function, if the period is 13, that means 2 pi over b, which is my formula for period, is equal to 13. Cross multiply, I get 13b is equal to 2 pi. Divide by 13, so I get a frequency, or a b value, of 2 pi over 13, which would be helpful if we wrote this equation. And since there's no shifts, I actually could write this equation right now. Oh, you know what? And as I say, they didn't ask us to write this function. All right, Miss Carnes, you got to read the question a little. Sorry, guys. We're going to write a cosine function in the form f of t. So we did need to write this function. Excuse me for forgetting that piece. So A, our amplitude is 12, but since we're starting at the minimum, I'm going to put a negative in front. Okay, and then I'm going to write cosine of my b value, which is 2 pi over 13, times t. You could put that in parentheses. If you didn't, you wouldn't lose credit. So that is not just extra, that is what the question asked me to do. Write my function in terms of t for f of t. Okay, so everything we did so far was to get us to really understand this function. How do we know amplitude? How do we know frequency? How do we analyze the fact that there were no shifts? The fact that they told us we were going, 12 above and 12 below sea level, and that we're starting right at our minimum. So if we do not need to shift anywhere, we're not graphing anything left of the y-axis, I am going to put my y-axis right on the left, or my f of t axis. And since we're going an equal amount above and below the x-axis, or in this case my t-axis, I'm going to put that center as well. Okay, so I'm going to probably count by twos. So 2, 4, 6, 8, 10, 12. Same thing here, 2, 4, 6, 8, 10, 12. Okay, now before I label my t-axis, let's go back to our period, which was 13. So if I want to figure out my critical value interval, that's always period divided by 4, which is 13 over 4, which is actually 3 1/4, or 3.25. So if I want to label that, I think I can skip probably 4 boxes here. 3.25, then another 4 boxes. That would be 6.5. We know that that should be the middle, since that's where, that's how long it takes to go from low tide to high tide. Another 4 boxes, add another 3.25 would get me to 9.75, and another 4 boxes gets me to 13. So we're ready to graph. We're starting this at low tide, so at negative 12. At 3.25, we come to sea level, or the middle. At 6.5, we are up at our maximum. 9.75, back at the middle. And a full cycle here gets me to 13. Let's sketch that with a smooth curve for this reflected cosine curve. Okay. Then it goes on to ask us a follow-up question. So it said people who fish in Carter Beach know a certain species of fish is most plentiful when the water level is increasing. Explain whether you would recommend fishing for this species at 7:30 p.m. Or 10:30 p.m. using evidence from the given context. So let's just break this down for a moment. As far as increasing and decreasing, let's just remind ourselves what that looks like. So increasing, you're reading your graph from left to right. We are increasing from low tide to high tide. And then we turn to decrease when we get to high tide until we get back to low tide. That is when the water level is decreasing. So if they're talking about 7:30 p.m., remember our x-axis, our t-values, are hours since 8:30 a.m. So let's just think about that for a second. If we're at 8:30 a.m. and then we think about the time until 7:30, what I'm doing there, 7:30 p.m., count up those hours, that's 11 hours. So let's look on our x-axis or t-axis and see where 11 would be. So 11 would be, let's just see, somewhere right around, between 9.75 and 13. So if you look, just get a color here, somewhere in between here, right, would be 11. So that means I'm going down the decreasing part of this curve. So I would not want to recommend 7:30 if the best time to fish is when the water level is increasing. So now let's look at 10:30. So if we go from 8:30 a.m. to 10:30 p.m., that's going to bring me now to 14 hours. So even though I don't see more of this curve, we know every 6.5 hours this cycle would continue. So let's just think about continuing this graph for a moment. If I went on another 4 boxes, 1, 2, 3, 4, this would bring me to 16.25, and that would also bring me back up to my middle if I were going to continue this cosine curve. So now I'm in an increasing part of my curve. So even though that's not what they're asking me for, they're asking me for 14 hours. 14 hours would fall somewhere between 13 and 16.25, which means I'm here in that increasing part of my function. So since this is increasing, I would say I would recommend that someone fishes at 10:30 since the water level would be increasing at that time. Would be increasing. Okay. So even though I kind of made a mess of my graph here, you would definitely not need to keep all of that. If you did make marks like that on your graph, there's nothing wrong with that. But as far as what we had to graph, we just had to graph that one cycle of cosine. Okay. A detailed key of this will also be posted on Canvas later today, so you could always look over my key and revisit this and just check, each part or rewatch the video for question number 1. Now, the rest of this lesson, we're just going to look at 4 other regions questions, quicker and not involving a graph, but definitely using all of the skills we've developed now with these graphing questions to answer them. So question number 2 talks about a Ferris wheel. In Chicago, it takes 7 minutes to make 1 full rotation. So again, that would be our period. The height in feet h above the ground of one of the 6-person cars can be modeled by this function, h of t. They tell us t is time in minutes. They want us to use h of t for 1 full rotation and find the car's minimum height. So if we are looking for the minimum height and we have our function, think again about what this function is telling you. It tells me I have a midline of y equals 80 and an amplitude of 70. So let's remember, amplitude is height above or below the midline. So if we go from the midline of 80 and we subtract our amplitude of 70, that would give me a minimum of 10. The other way you could do this would be, think about the original range. If the amplitude is 70, without a vertical shift, we would think the range is negative 70 to 70, but now we're shifting up 80. So we would have added 80 to both our min and max, which would bring our range to go from 10 to 150. So 10 is the minimum. 150 would be if they asked us for the max. Okay, number 3. They're asking us, based on some climate data that's been collected in Bar Harbor, Maine, the average monthly temperature in degrees can be modeled by this function. I'm just going to highlight the function. All right, this is Bar Harbor. The same governmental agency is collecting average monthly temperature for Phoenix, Arizona. And for Phoenix, Arizona, they found this function to model its average monthly temperature. Okay, which statement cannot? So anytime I have a question that says not, I just need to like bold that so I don't forget later when I'm answering this question that I'm actually looking for what is not true. Can be concluded based on the average monthly temperature X months after starting this collection of data. So choice number 1 says the average monthly temperature variation in Bar Harbor is more than in Phoenix. So if we're talking about the variation in temperature, we're really talking about the range as if we subtracted our max minus our min. So let's just start breaking this down. So Bar Harbor, if you take its midline of 55.300 and let's maybe start with the minimum, and you subtract the 23.918, so here's our amplitude, here's our midline. So let's take the midline and subtract that amplitude. You're going to get 31.386. Now, if I want the maximum, I'm going to take those two numbers and add them. So if I start at the middle of 55.3 and add the 23.914, I'm going to get 79.214. So if I think about the variation there, if you did max minus min, the range or variation in temperature would come out to be 47.828. Okay, so that's the variation in temperature in Bar Harbor. Now let's look at Phoenix, Arizona. Okay, so for Phoenix, we're going to, again, think about its min. The midline on this curve is 86.729, and the amplitude is 20.238. So if we take 86.729 and subtract the 20.238, we're going to get 66.491. The maximum, take those numbers and add them, you're going to get 106.967. And now let's subtract those numbers to see the variation from max to min. You're going to get 40.476. So the variation in Bar Harbor is more than the variation in Phoenix, and they're saying it is more in Bar Harbor, so that's true. We're looking for what's not true. Okay. The midline average monthly temperature for Bar Harbor is lower than the midline temperature for Phoenix. So let's go back here. The midline temperature, that's just a number right off the equation. So for Bar Harbor, it was the 55.300. And for Phoenix, the midline temperature was 86.729. So they're saying the midline average monthly temperature for Bar Harbor is lower than Phoenix. That's also true. Okay. The maximum average monthly temperature for Bar Harbor is 79 to the nearest degree. So let's look. Yeah, 79.214. I agree. We would round that down to 79. So it must be choice 4. Let's see why. The minimum average monthly temperature for Phoenix is 20 degrees to the nearest degree. Phoenix, the minimum, we can see here, the minimum is 66 to the nearest degree. So that one is the one that is not true. Okay. Number 4, a sine function increasing through the origin can be used to model light waves. Okay, so then they tell us violet light has a wavelength of 400 nanometers, over which interval is the height of the wave decreasing only. Okay, so let's think. All they told us to start was that it was a sine function. So let's just think about our parent function for sine. That we start in the middle, we go to our maximum, we go back to the middle, we go to our minimum, and then we come back to the middle. Okay. They told us, however, that this, I feel like I didn't get all the way through. Okay. That this light has a wavelength of 400 nanometers, which is really giving me the period. It's wavelength, so that means this is 400, which means halfway through, this would be 200. And then a quarter, this would be 100, and this would be 300. Since sine, all of these critical points happen, period divided by 4. So if period is 400, we really just worked backwards with the critical value interval, which would be 400 divided by 4, which is 100. So they want to know, where's the height of this curve decreasing only? So we just talked about decreasing in the last example. We're looking at this curve from left to right. It is increasing from 100 to 200. From 0 to 100. And then it starts to decline. So to decrease from 100 through 200 all the way down to 300, and then it starts to increase again. So it is decreasing from 100 to 300. If you looked at the first choice, 0 to 200, it's both increasing and decreasing. From 200 to 400, it's decreasing and then increasing. And from 300 to 400, it is increasing only, just so we can rule out the other choices. Okay, and then the last question here gives us a function h of t in centimeters. It's the height of a piston, where t represents the number of seconds since the measurement began. Determine the average rate of change. So here they're asking us to find the slope of the piston's height over the interval 1 to 2, which means we're finding change in y over change in x. And if we're going from 1 to 2, those are our x values, and we need to plug them into our function to get the y's. Now notice how all of these functions, the b value is in radians. So right now your calculator should be in radian mode. So you're going to take your calculator, you're going to type in the function. So you're going to type in 12 cosine pi divided by 3 times x. And then you're going to add 8, okay? Make sure you're in radian. And then you can go to your table. And at 1, you should be seeing a value of 14. And at 2, you should be seeing a value of 2. So let's see. So just so we see the points over here, 1 is with 1 comma 14 and 2 comma 2. So, sorry guys. So it'll be 2 minus 14 over 2 minus 1. So negative 12 over 1 gives us an average rate of change from 1 to 2, which is the number of seconds. The average rate of change is negative 12. Okay, so that was the first part of the question. Then they say, at what values of t to the nearest tenth of a second does this function equal 0 over the interval 1 to 5? So now I'm looking at my calculator, and if you do look from 1 to 5, in your table, you can see that the y values go from 14, 2, then negative 4, then 2, then 14. So as far as hitting 0, somewhere between 2 and 3 seconds it's hitting 0, and then again somewhere between 3 and 4 seconds it's hitting 0. So let's actually go to the graph. So if you want, in your calculator, you could hit zoom 7 for zoom trig. And now again, we're only looking from 1 to 5. So let me just quickly get my camera. And bear with me for a second here, guys. Oh. Maybe you can't see what you're doing, Miss Carnes, because your case was blocking your calculator. Sorry, guys. Okay. All right, so if I want to change this for a moment, I'm going to go to my window. I just want to see from 1 to 5. Okay, I'm going to leave everything else. Okay, so I want to find the 0, so I'm going to go to second trace 0. Okay, so left bound of this 0 would be a little bit above, then you're going to hit enter. Then you're going to go a little bit below, hit enter. Then you're going to go close to that 0 and hit enter. So this 0 is 2.196. I would write that down. I will in a moment. Then I'm going to go second trace 0 again. Go find the other one. Okay, this time I'm going to go a little bit below, hit enter. A little bit above, hit enter. And then right on the functional, hit enter. And that one's about 3.8031. Okay, so let's come back here. Okay, so they want us to write to the nearest tenth of a second over the interval 1 to 5. Where does the function equal 0? So when t is 2.2 and when t was 3.8. And they do say to justify, so we can just say we found we found the values of t that make h of t equal 0 using our graphing calculator. And that's enough. Because you just need to justify mathematically how did you do it, and that's how we did it. We typed it into our calculator, and we used the 0 function on our calculator. Okay, guys, I hope this video was helpful. Please rewatch it at any point if you need help with any of these 5 questions, especially the one with the graph. All I ask, now that you've followed along with the lesson, hopefully in your notes packet, you are going to complete homework 10.8 in your packet for the submission for today. So again, I made the due date now 3:30 each day, the normal end of our school day. If anyone is having trouble though submitting by the end of the day, please just email me. As far as deadlines go, I just really hope that you're practicing and you're coming to a better understanding of this unit day by day. We're really focused on learning here and making connections with this content, and we're really taking our focus away from grades. So I think that's a little bit of a burden off a lot of our shoulders, and we can really just focus on learning. And I am going to try and set up a virtual extra help. I'm going to look into doing that this week, and I will be in touch about that so we can actually see each other and communicate, and you guys can ask questions live to me.